A funny story about that. You say that tripped over the wire. We installed in one office that was using the DEXA sensor, and the hygienist kept lifting her leg and walking like she was going over something when we were using the wireless. And she was so used to walking over the cord, she was mimicking it every time. She couldn't, it was a habit for her. So she obviously had tripped on that wire a number of times and done the same thing that happened to your wife. So it was kind of, I mean, I was holding back laughing because I didn't want to embarrass her, but it was pretty funny.
So, Eric, I'm glad you're asking this question about the Bluetooth, because when we first started and we had the idea, let's make a wireless sensor, there were two clear candidates. One was Bluetooth and the other was Wi-Fi. Wi-Fi has a much larger bandwidth. You can transfer a lot more data a lot faster, clearly. It's unbeatable. You know, the Bluetooth is nowhere close to that. The highest Bluetooth bandwidth is 150 kilobytes per second. However, to make the intraoral sensor comfortable and to actually be one of the most compact, actually the most compact sensor in the market, you have to live with a battery that is no larger than almost, the half a nail of your finger. So you can see it here. And this battery has a capacity of about 18 milliampere hours. 18 milliampere hours is about 100 times less than what your iPhone has. So with 100 times less the power what you have in a regular iPhone, you have to have a product that is suitable and able to take actually more than 200 X-rays before you need to recharge the battery. So we had to go with Bluetooth, because Bluetooth can do all of that and with very low power consumption. Of course, there is no magic bullet here, at least none that we knew or we are aware of off the shelf, because Bluetooth has, as I mentioned, 150 kilobytes per second. So how do you transfer 2.5 megabytes in about 4 to 5 seconds? Well, that's where, again, the ingenuity of our team came to play, because we actually, for the first time ever, invented a new compression algorithm that is implemented on the chip inside the sensor. So when we capture the 2.5 megabytes of image, in real time, in a matter of a fraction of a second, it's compressed without losing any of the data. And then the Bluetooth sends it over in about 4 seconds. And we already have the CR clinicians review that has told us that this is in no way affecting the workflow. I mean, a typical wire sensor will send the image in about 3 seconds, where maybe about a second or two longer, which is perfectly fine for the workflow. So it's really a feat of technology to do all this, first in this sector of intraoral dental imaging. And that's the main reason why we went with Bluetooth, because it has such a low power, and we were able to actually accommodate the speed by creating this new algorithms that run on the chip simultaneously with the exposure.